The foundation of all programs is data. It is data that computer programs operate on. Variables, in turn, are fundamental to any programming language, as they allow us to store this data so we can perform operation on it. Today, we will learn how to create them in Python. Additionally, we will get to know their basic types and properties. Let's get started. Let's start by explaining what variables are. They are essentially places in computer's memory where the data is stored. Such data can be numbers, pieces of text, logical values, or others, often more complex data structures. We assign a unique name to such data, through which we gain access to them. A good example would be variable name, to which we assign name Bob using equals sign. In this simple way, we have created a variable storing textual information, represented by a string of characters enclosed in quotation marks. But as I have already mentioned, we don't have to limit ourselves to text. We can create more variables storing data of different types. Let's create variable age, representing Bob's age as an integer, height being a floating point number, and boolean value is married, including whether Bob is married. We will display all this information using an already known print function. Variables once created can be changed in the same way. Assigning a value to the certain name creates a new variable, and reassigning the value to the same name overrides the stored value, even if the new value is of a different type. Python is so-called dynamically typed language. This means that the type of variable is determined by the type of data assigned to it. The interpreter will not raise an error assigning a new value. It's up to the programmer to ensure that the variable stores the appropriate data types consistent with the assumption of the code. In many programming languages, this is not possible or requires explicit indication that the variable can accept different data types. It is now worth explaining the rules of naming variables. First and foremost, variable names must be unique within their scope. We will discuss what variable scopes are on another occasion. When choosing a name, we must adhere to certain limitations. Variable names must start with a letter or an underscore. They cannot start with a digit. Variable names can contain letters, digit, and the underscore, but cannot contain other special characters like exclamation mark or hash, for example. Variable names are case sensitive. The variables age and age with the capital A are two different variables. You cannot use reserved keywords as a variable names. Words like if, else, def, class, return have special meanings in Python. The list of keywords is much longer. When naming a variable, we can do it in many ways and still comply with the aforementioned conditions. Let's introduce another built-in function, type, which returns the type of variable passed to it. As you can see, name is of type str, that is a string. As I have already mentioned, variables can store different data. In this episode, we will focus on 4 of their basic types: integers, floating point numbers, boolean values, and strings. A variable being an integer is declared by assigning a regular number. To check, we display it and its type. We can perform all basic mathematical operations on integers using the appropriate operators. Addition using the plus sign, subtraction using the minus sign, multiplication using the asterisk, division using the slash. The result of these operations are also integers, except for division, which by its nature return fractional values of type float. However, there is integer division whose result is an int. We perform it using a double slash. In a similar way to int, we create variables of type float. We assign a value in decimal form, that is the number with so-called decimal places. A dot at the end or a dot followed by digits tells Python that it is dealing with the floating point variable. Similar to values of type int, we have access of basic mathematical operation, addition, subtraction, multiplication, and division, with the result of this operation now being treated as a number of type float. Somewhat different objects are Boolean values. They can take only two possible states and are represented by two reserved names in Python, true and false. Values of type bool are suitable for describing situations that by their nature have only two possibilities and no others. They support basic Boolean algebra operation such as logical OR, logical AND, or negation. The string type, or in other words, a sequence of characters, is used to record longer or shorter text. We assign a value of this type by placing it between quotation marks. It's worth mentioning that among the sequence of characters, which usually represent symbols such as letters, digits, or punctuation marks, there are also so-called special characters that do not have any direct visual representation, but rather control how the text is displayed. Examples include the new line character represented by a backslash and the letter N, or the tab character represented by backslash and the letter T. As I have already mentioned, we create strings using quotation marks, but we can do this in four different ways: with a pair of single quotes, with a pair of double quotes, with a triple single quotes, or with a triple double quotes. The difference between triple quotes and those with a single characters is that the triple ones allow you to write string with line breaks. It means write text in multiple lines. Those using single characters for opening and closing the string can contain text written in a single line. Some of the operators we learned today when discussing numbers int and float work a bit differently on strings. The addition sign, for example, allows concatenation of two strings. On the other hand, the asterisk repeats the given string's content. The capabilities of strings certainly do not end here. Whole range of possibilities is open to us by the construction consisting of a pair of square brackets. It allows access to selected element of the string, revealing the nature of the data structure it is. A string is a sequence of characters to which we can gain access by providing a character's index between the square brackets. By the word index, we mean the number of the position where the character is located. Let's pause for a moment and consider the word Python, which consists of 6 different characters. Each subsequent character has an assigned index, which is its position in the sequence, where the first one is counted from 0 and the last one is at the position number 5. It is also possible to refer to characters by counting their position from the end. We use negative indices for this, where -1 is always the last character, and in our case, the first character is available at the index -6. It is possible to obtain an entire sequence, a slice of the string, by providing the starting index and the ending index, separated by a colon. However, it is important to remember that the ending index limits the substring but is not included in it. This is how use of these possibilities looks in practice on an example variable. In addition to retrieving elements of the string, we can check whether a given string contains another string using the in operator, which returns true if the given string is contained in the variable text or false otherwise. Among the many built-in functions available in Python, it's worth mentioning len, which returns the number of elements in a sequence such as a string. Additionally, an object of type str offers many methods, which are instructions associated with the object itself or its type. I will talk more about methods when discussing classes in Python. What is important for us is that the object, like a string, has access to many instructions enabling a wide range of operations. On the screen, I'm showing a list of selected methods that are commonly used. There are more of them, and for the full list, I refer you to the official documentation on python.org. In addition to a brief description on the screen, we will see a simple example of what each of them does. The method upper and lower returns the string in uppercase and lowercase letters respectively. Strip removes white space characters like spaces from the beginning and end of the text. Replace, as the name suggests, replace all occurrences of one substring with another. Split divides the string into substrings at the point where the separator occurs. The join method essentially performs the reverse operation. It joins a sequence of strings into one. And the find method returns the index of the first occurrence of a substring in the string. And with this discussion of selected methods, I would like to conclude this episode. The documentation offers much more, often more specific instructions, so I encourage you to visit it as often as is possible and whenever you need to. Today, we have covered variables and the most important properties of the basic types. This should give you a solid understanding and intuition on how to use them. That's all for today. Thank you for your attention and see you in the next video.